So in this lecture, we're going to discuss some examples or additional examples for the solutions of a system or systems of linear equations by Cramer's rule. So let's start with the first example. So we're given three equations and we have three unknowns. So our first step again is to transform our given equations to a matrix or in its matrix form. So we have here will be the values that would represent matrix E or your coefficient matrix, and this one will be your vector column or column vector B, which represents your constants. So for our matrix, so we'll have now so we have 1, 2, 3. We have 3, 1, 2, 2, 3, 1. Wherein each column would represent our unknowns. We have for first column we have A, second column B, and the third column C. Then we also have your constants. So we have 4, 5, and 6. So for Cramer's rule, what we want to do is to determine or solve for the determinant of a matrix wherein for determinant of matrix A, small a, this will be the matrix wherein we substitute the column of matrix E with our constant. Then we also want to solve for determinant B, determinant C. So this will be the determinants of the matrices in which our coefficient matrix have been substituted with the values of your constant or vector column or column vector of the constants to the respective unknowns. As well, we are going to compute for the coefficient or determinant of your coefficient matrix E. Okay? So, to start, we solve first for the determinant of your coefficient matrix. So, we have here your coefficients. So, we now have, so downward, so that will be 1 plus 3 times 3 times 3. That is 27. So, plus 2 times 2 times 2 is 8. So, minus upwards, that's 6 plus 6 plus 6. So that will now be equivalent to 8. That is 36 minus 18, or the determinant of your coefficient matrix A is equal to 18. So next, we solve for your determinant of A. So we can solve for the value of A, which is solved as the determinant of the matrix, wherein we substitute the column of A divided by the determinant of your coefficient matrix. So what we want to do is to transform or replace this with our matrix B. So in that case, we'll now have 4, 5, 6. Then, so this is for E. So 3, 1, 2, 2, 3, 1. So substitute. with. Okay, so this will now be your matrix. So solving now for the determinant of this matrix. So we have 4 times 1 times 1. That is now 4. So plus 3 times 3 times 6. So that is 54. So plus 2 times 5. That is 20. So minus, so upward, 6 times 1 times 2 is 12. 2 times 3 times 4, that is 24. So plus 2 times, that's 1 times 3 times 5, that is 15. Or the determinant of E now is equal to, so that's 78 minus 51, or this will give us a value of 27. So for your determinant or value of E, determinant of matrix E, 27 divided by our computed determinant of the coefficient matrix is 18. Or 27 over 18 will give us a value of 3 over 2. So next, we move on to solving for determinant of B in order to solve for your unknown B. And we can do that by replacing again the column of B with our column vector. So this equation now, or this matrix, will become 1, 2, 3. This matrix or this column will now become 4, 5, 6. We have 2, 3. So given now this matrix, we can now solve for your determinant of B, which is equal to 1 times 5 times 5, 1. That is 5 plus 4 times 3 times 3. We get 36. So plus 2 times 6 times 2 is 24. So minus upwards 3 times 5 times 2, 30. 6 times 3, we get 18. 1 times 2 times 4, we get 8. Or that is now is equal to 65 minus 56. Or this is simplified as 9. So with that value, we can now solve for B, which is the determinant of B divided by the determinant of your coefficient matrix, or that's 9 over 18, giving us a simplified value of 1/2. So next, we have determinant of C, so we can solve for the unknown C, and we can do that by replacing the column representing the coefficients of the unknown C with our column vector of, so we replace C with your column vector of the constants. So with that, we now have 1, 2, 3, 3, 1, 2, and we replace it by 4, 5, 6. Okay. So determinant of C now is equal to 1 times 1 times 6, 3 times 5 times 3, 4 times 2 times 2, minus, so upwards, 3 times 1 times 4, 2 times 5 times 1, 6 times 2 times 3, or simplifying, we have now equal to 67 minus 50, or that's equal to 9. So substituting now, the unknown C is computed as the determinant of the matrix, wherein we have replaced the C column divided by the determinant of your coefficient matrix. And that will now be equivalent to 9 divided by 18, or simplified value is 1 half. So therefore, our answer now, our unknown values A, B, C is equal to 3 halves, 1 half, and 1 half. So you can list it as simply A equal to 3 halves, B is equal to 1 half, C is equal to 1 half, or you can write it in matrix form. So let's have another example, number 2. So this is again 3 equations with 3 unknowns. And by Cramer's rule, we again transform our matrix or our equations into a matrix. So we'll have for the coefficient, that will now be 1, negative 2, 3, negative 3, 1, negative 2, 2, negative 3, 1. And for our constants, that will be negative 4, 5, negative 6. Okay? So this one now is your coefficient matrix. This one is our column vector. So let's start our solution. So we solve first our determinant A. So determinant of your coefficient matrix now is equal to 1 times 1 times 1. So plus negative 3 times negative 3 times 3, we get 27, plus 2 times negative 2, negative 2, that is 8. So minus, pataas, 3 times 1 times 2, 6. Negative 2, negative 3, 1. 1, negative 2, negative 3, 6. Or that is now equal to 36 minus 18. Or the determinant of our coefficient matrix A is equal to 18. So next, we solve for the determinant of matrix A, wherein we substitute now the column representing A with our constants. So with that, we'll now have 4, negative, or that is negative 4, 5, negative 6. So negative 3, 1, negative 2, 2, negative 3, 1. Okay? So with that, we now have the determinant of the matrix. The new matrix will now be negative 4, 1, 1. That's negative 4 plus negative 3, negative 3, negative 6. So that's plus negative 54. That's minus 54. And then we have 2 times 5 times negative 2. So that's minus 20. So minus upward, we have negative 6 times 1 times 2, negative 12. Negative 2, negative 3, negative 4 is 24, negative. And 5, negative 3, 1 is negative 15. Or we now have the determinant of the matrix is negative 78 minus 51. Or this is now equal to this is minus 51. And that's equal to negative 27. So therefore, the value now of the unknown E for our given equation or given system will be determinant of the matrix, that's negative 27, divided by the determinant of the coefficient matrix, which we have solved as 18. So simplifying, the value now of E is equal to negative 3 over 2. So next, for B, this is to solve now for the unknown B. And we can do that by substituting the column representing the unknown with our constant. And our constants are negative 4, 5, negative 6. So we'll now be transforming this into a new matrix, negative 2, 3, 2, negative 3. Okay. So with that, we now have your determinant of matrix B is equal to 1, 5, 1. It's 5. Negative 3, negative 4, negative 3, negative 3. Then we have 2, negative 2, negative 6, 24. So minus, pataas, we have 3, 5, 2, negative 6, negative 3, 1. Then we have 1, negative 4, negative 2. Or this is now equal to we have 65 minus 56, which is now equal to 9. So, substituting now, the unknown B is equal to the determinant of the matrix B, in which we have substituted the column it represents, divided by determinant of the matrix of coefficients. So, we have here, determinant of B is 9. We have computed determinant of the coefficient is 18, or B now is equal to 1 half. And then, lastly, we have C. So to solve for C now, we substitute the column representing the unknown C. So, so we substitute C with your constants. So we'll now have a new matrix. 1, negative 2, 3, negative 3, 1, negative 2. And that will become negative 4, 5, negative 6. Okay. So for your determinant of C, that will now be 1, 1, negative 6, negative 3, 5, 3, negative 45, negative 2, negative 4, negative 2, negative 2, negative 16. So minus 3, 1, negative 4, negative 2, 5, 1, negative 6, negative 3, negative 2, or we now have the determinant of C is equal to negative 67 minus negative 58, or that is equal now to negative 9. So solving now for the value of the unknown C, we now get the determinant of the transformed C divided by the determinant of the coefficient. It's negative 9 over 18. Simplifying, the value of C now is negative 1 half. So again, we can write our answers as a list. So we have A is equal to negative 3 halves, B is equal to 1 half, and C is equal to negative 1 half. Or we could also write this again in matrix form. The unknowns A, B, C is equal to 3 halves, 1 half, negative 1 half. So that's for our Kramer's rule.